The next speaker is Dr. Mathew Kurian, and he will be talking to us on a very interesting as well as a complex topic, Phacodynamics, machine settings, and customization.
Thank you, Arup. So Phacodynamics is understanding the machine, and the forces that act on the nucleus through the machine are the jackhammer of the phacoemulsification, irrigation, and aspiration. I have no financial interest for this presentation. So there are 5 dynamic surgical components: aspiration flow rate, vacuum and bottle height, and the ultrasound power. All put together work, and the incision size is what actually keeps these things in certain critical limits. The ultrasound power, sonics, generates the heat, and the rest of it is to cool down and prevent corneal wound burns. The first step, of course, before we start anything is priming and tuning, which often we don't do. The staff will be doing for us, but we need to understand what they do. Priming is to check the fluidics, and tuning is to check the sonics of the phacotip. The handpiece converts the electrical energy into mechanical energy, and today almost exclusively we have piezoelectric crystals in the handpiece. 4 or 6 is a current standard. The frequency, the terminology is basically the speed at which the phacotip moves, and it is fixed for the machine. Higher the frequency, the greater the efficiency of fragmentation, but also more the heat. The power is varied by altering the stroke length or the amplitude depending on the machine that we use. The phacotips are what actually deliver this mechanical energy into the eye and break the nucleus fragment into pieces. A thinner, sharper one is preferred. This will last longer, this will last shorter. The larger the opening, the easier to remove fragments. The smaller the opening, you have to spend more energy to break the nucleus into smaller pieces. Lots of angulations are available, but today I think we have come to a conclusion that approximately a 30 or a 40-degree tip would be the best. Recent advances in the tip are Oertli's Easy Tip, which is very good at maintaining the chamber stability, and the Balance Tip by Alcon, which is fantastic for nucleus emulsification. There was a thought that mechanical, cavitation and acoustic energy all work on the eye, but if we increase the power, you will see that at a certain point, small bubbles, which is the cavitation bubbles, will appear at the tip. And then as we increase the pressure inside this hyperbaric chamber, you will see that the cavitation bubbles get cancelled. So Jamie Zacharias made this award-winning video where he was able to demonstrate that with cavitation and after increasing the pressure without cavitation, the efficiency of the phacotip in emulsifying or embedding into the lens matter was equal. So this was actually a landmark concept because we wanted to maximize the mechanical jackhammer effect and reduce the cavitation, because cavitation is what causes the free bubbles, the free radical formation and damage to the endothelium. Power settings range from 0 to 100 in the older machines, and in today's machines we have a method of able to start from a threshold and then move to higher. And there are fairly reliable guides on how much power to use for trenching, which is slightly more, and for the nucleus emulsification it's slightly less. Panel mode is where there is continuous from the beginning of foot position 3 to the end of foot position 3, and linear control by the surgeon. In more experienced individuals, you can have a control starting from the beginning with less amount of energy to high energy at the end of the foot pedal. Variations of this were required because there was it was noticed that corneal damage, etc., was more. So burst is where you have a duty cycle which is linear and the power is fixed. So as we go down in foot position 3, it tends to become continuous at 100 whatever preset level, whereas in pulse the duty cycle intervals are fixed but the power increases as we go down in foot position 3. Further modulations of this were to have microburst and hyperpulse, and that is to give more effective control of energy. The irrigation part, we want to balance the infusion into the eye with the amount of aspiration and wound leak that can happen, and is governed by the bottle height. Pumps, different, peristaltic pump, vacuum pump, but actually today's machines, the difference is very minimal, and we need not really worry so much about that, other than to know that in peristaltic pumps you can independently control these two variants. Aspiration flow rate governs the followability of the piece to the eye, while the vacuum is the holdability of the piece, and the rise time is the time taken for the system to reach the preset vacuum. This is surge is one of the most important concepts. The IOP rises when the fragment is occluding the flow, and then when there is a sudden release, you have a drop and chamber collapse can happen, and this is when complications occur. The modifications that we can do is surgically to reduce outflow and increase inflow, but machine specific, the balance tip from Alcon, the bypass system, AMO fusion fluidics, cruise control, the easy tip and SPEEP technologies are all variations to make it better and safer for the surgeon. Thank you.